The surface image of Proxima B, captured by the James Webb Telescope, is essentially the clearest image of Proxima B in historical context. This incredible discovery stumbles upon amazing knowledge about an exoplanet that might be habitable. It obliges us, as we embark on a journey through space, to discover the mysteries of Proxima B and determine whether it might be the next Earth. We ought to take off into the vastness of the universe, where a mysterious planet exists in the habitable zone of its star, Proxima Centauri. This planet is not just any ordinary rock, it's real. Proxima B is discovered just 4.2 light-years away from us. It is covered in mysteries and wonders. Could it be another Earth, with seas and life that grows there? Wait, there's more. Proxima Centauri B isn't alone in that system. It orbits the red dwarf star Proxima Centauri, which shares the system with Proxima Centauri C. Who knows what additional mysteries the galaxy holds? We might even have a second companion we haven't figured out yet. Proxima Centauri produces approximately the same amount of energy from its star as Earth receives from the Sun. Could this truly mean there may be water, maybe even life, on its surface? As we venture outside of our solar system, we encounter an entirely new universe of exoplanets, planets that orbit stars other than our Sun. With billions of stars in the universe, there are countless opportunities for exoplanets. Some exoplanets even defy boundaries, wandering unattached to any star, like travelers in space. Why is this image of Proxima B so striking? Proxima Centauri B is one of the most groundbreaking discoveries. It's a captivating planet with a year that is only 112 Earth days long and a distance from its star that is generally closer than Earth is to the Sun. In fact, one side of the planet is constantly washed in sunlight, while the opposite side remains in everlasting darkness. Now let's examine Proxima Centauri, the star around which Proxima B revolves. The Alpha Centauri system includes Proxima Centauri. This triple star system includes Rigil Kentaurus, also known as Alpha Centauri B, and Alpha Centauri A. These stars combine to form the closest star system to our solar system. Alpha Centauri A and B form a binary system, consisting of G and K-type stars that appear as one star in the Centaurus constellation. They are the third brightest stars in our night sky, with a peak luminosity of under 2.7. Proxima Centauri, also called Alpha Centauri C, is a red dwarf, an M-type star, found approximately 0.21 light-years from the other two stars, about 4 times the distance between Earth and the Sun. It is the closest star to us. Proxima literally means the closest in Latin. It was discovered by Scottish astronomer Robert Thorburn in 1915. Despite being our closest celestial neighbor, it is not visible to the naked eye, having an apparent magnitude of 11.13, which is significantly fainter than the human eye's limit of 6.5. But don't let that fool you. Proxima Centauri is still a star worth studying. Red dwarfs like Proxima Centauri are among the most efficient in terms of energy production. Though they may not produce much energy, their internal convection processes enable them to shine for trillions of years. Generally speaking, Proxima Centauri will continue to be a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still debated. For one, it's a flare star, meaning it has frequent and intense solar explosions. As a low-mass star, its habitable zone would be much closer to it than the Sun's is to Earth, projected to be somewhere in the 0.23 to 54 cents range. But that proximity brings its own dangers. Proxima B is bombarded with ultraviolet radiation from its star, much stronger than what Earth receives from the Sun. It's so extreme that even the lightest particles, hydrogen, nitrogen, and oxygen, can be stripped away. And just because a planet is at the right distance from its star doesn't mean it can support life. Proxima B may not have a stable atmosphere, which is essential for regulating temperature and maintaining a water-friendly surface. Without it, life would be exposed to harsh space weather, making it nearly impossible. So, while Proxima B might appear Earth-like on the surface, it is still a long way from supporting life. Scientists continue to exercise caution, as many factors render it inhospitable. The mission to reveal the truth. The mission to reveal the truth about Proxima B continues. One tool that has garnered the attention of astronomers is the James Webb Telescope. After years of anticipation, it was finally launched in late 2018 and is expected to help determine whether life exists on Proxima B. As with everything in science, things are never as clear as they seem. Several adjustments were required to ensure that the James Webb Telescope provides precise images. As Abby Taber, a theoretical physicist at Harvard, explains, if a planet like Proxima B can, besides absorbing light from its star, emit it as infrared light, The James Webb Telescope was made precisely for this, to detect infrared light. It can capture images of this light from the planet's surface and look for patterns that may indicate the presence of water or an atmosphere. But what if the planet has an environment that makes life difficult? The presence of an atmosphere does not guarantee that life exists. Ed Turner, an astrophysicist at Princeton University, warns that Proxima B could be like Venus, with a dense atmosphere and extreme temperatures, conditions that would make life impossible. The challenges and possibilities. The journey to decipher Proxima B's mysteries is not without its challenges. While the James Webb Telescope holds promise, there are other factors to consider. With mounting costs, space scientists feel the urgency. But the benefits are even greater. The chance to investigate the unknown and discover the secrets of a distant planet that might hold life is a pursuit worth chasing. If the exoplanet is habitable, might we visit it one day? It is the closest exoplanet to us, which makes it especially captivating. Almost like exploring our own backyard. Even more exciting is that it's roughly the same size as Earth, and its position in the habitable zone suggests it could indeed have life-supporting conditions. Its proximity makes it a perfect target for our search for life beyond Earth. However, traveling there is not an easy task. It would take 75,000 years for a spacecraft like Voyager 2 to reach the Proxima Centauri system. Nonetheless, a proposed solution is solar sails, ultra-thin sails that use solar pressure to propel spacecraft. This would eliminate the need for fuel and open new possibilities. Conclusion. Cutting-edge technologies provide exciting new perspectives on the possibility of life beyond Earth. But like any ambitious endeavor, there are limitations. The existence of an atmosphere doesn't always mean life is possible. Proxima B could resemble Venus, with intense heat and a hostile atmosphere. If emissions are detected by the James Webb Telescope, they may show only 5% of brightness from the daytime side. That may not seem like much, but when dealing with a star less bright than our Sun, it's significant. If advanced civilizations existed on Proxima B, perhaps they could even use orbital mirrors to reflect sunlight from day to night sides. How cool is that? Proxima B's discovery has captivated scientists and space enthusiasts alike. A new era of exploration. The possibilities Proxima B represents extend far beyond scientific curiosity. It symbolizes the threshold of a new era in human exploration. For the first time, we are beginning to look not just within our own solar system, but beyond, toward potentially habitable worlds orbiting distant stars. Proxima B is not just a speck in the sky, it's a mirror reflecting humanity's deepest questions. Are we alone? Could life take root elsewhere? Could we one day call another planet home? What makes Proxima B especially compelling is its balance between familiarity and mystery. It may share Earth's size and position within a star's habitable zone, but it remains shrouded in uncertainty. Its environment, geological activity, and atmospheric composition are all still under investigation. Every new data point adds a brushstroke to an unfinished painting, revealing more, yet deepening the mystery. Technological hurdles and global collaboration. To unravel this mystery, global collaboration is essential. Nations, space agencies, universities, and private companies are beginning to pool their resources and intellect in unprecedented ways. Projects like Breakthrough Starshot, a mission to develop small, lightweight spacecraft propelled by laser-powered solar sails, have already begun drawing plans to reach Proxima Centauri within a single human lifetime. These missions, while ambitious, come with technological and ethical challenges. How do we send a craft that can survive decades, even centuries, in the harshness of interstellar space? What happens if we discover signs of life? What are our responsibilities? The very questions we face now echo those that confronted explorers in centuries past. Should we go? What will we find? And how will it change us? Philosophical reflections. The search for life on Proxima B is not just a scientific quest, it's a philosophical one. It forces us to confront our place in the cosmos. For millennia, humans believed they were at the center of everything. The Copernican revolution dislodged Earth from the center of the universe. The discovery of Proxima B may be the next great shift, one that redefines life itself as a cosmic phenomenon, not just a terrestrial one. And if we do find life, what kind will it be? Microbial? Complex? Intelligent? Or perhaps we'll find no life at all, only a beautiful but barren world, a silent witness to the limits of habitability. Even then, Proxima B will have taught us something invaluable, about the fragility of life, the uniqueness of Earth, and the endless possibilities that lie among the stars. Looking ahead. In the years ahead, as telescopes grow stronger and missions become bolder, Proxima B will remain at the center of the conversation. Future probes might one day scan its surface, analyze its terrain, and perhaps even send back images of its landscape, sun-drenched on one side, forever night on the other. And who knows? Maybe one day, not just robots, but people, scientists, explorers, dreamers, will walk upon its soil. Maybe they'll look back toward the pale blue that is Earth and marvel at how far we've come, not just in distance, but in imagination, cooperation, and hope. Proxima B may or may not be our next home. But it is our next frontier. Exoplanets expand, and the dream of the pursuit of extraterrestrial life gets closer to reality. Conclusion and final thoughts. There are numerous planets waiting to be found in the universe. These planets come in all shapes and sizes, some being gigantic gas giants, whereas others are similar to our own planet. But what do we know about them? One type of exoplanet that has drawn attention is the gas giant. These are a target of space scientists. The chemical makeup of these planets is similar to Jupiter and Saturn, but they are much larger. Some of these monstrosities are named super-Jupiters, which are larger than even the largest planet in our solar system. Yet that's not all, there are also hot Jupiters, gas giants that orbit extremely close to their host star. These planets exist in sweltering environments with temperatures that could melt metal. Imagine seeing such a planet up close, with its violent storms and extreme heat. In addition to gas giants, Neptunian giants are also found, exoplanets with sizes comparable to Uranus and Neptune. Among these are hot Neptunes and small Neptunes, which are smaller and closer to their host stars than their gas giant relatives. These planets are often shrouded in mystery, with atmospheres difficult to study from a distance. And let's not forget the Earth-like exoplanets. These resemble our own planet and come in sizes ranging from smaller than Earth to twice its size. Some, known as super-Earths, have masses more than twice that of Earth, despite being lighter than Neptune. One of the most intriguing exoplanets recently discovered is Proxima Centauri b, which orbits the star of the same name. This planet is considered a super-Earth, with an estimated mass of 7 Earth masses. Although it is close to its host star, it is still too far away to be in the zone of habitability. Proxima Centauri b isn't alone, it has a companion, Proxima Centauri c, much farther from the star. This planet has an orbital period of about 5 Earth years and was discovered in 2020 using pre-recovery Hubble data. Even more interesting about Proxima Centauri is that it seems to be an extremely bright world, possibly due to the existence of a ring system. This adds even more to discover within the Proxima Centauri system. In 2019, astronomers detected a shift in the speed of the star's orbit, which could be the result of another planetary companion. If confirmed, this planet will be called Proxima Centauri d and will be roughly the size of Mercury or Mars. Imagine living in an area where the night sky is filled not only with stars, but with countless different planets, each with its own distinct characteristics and orbits. The universe is full of unexpected discoveries, and exoplanets are just one of them. With new discoveries being made regularly, it's an exciting time to be a space scientist. While we presently lack an accurate count of exoplanets, we know they exist, just as we are familiar with the stars that illuminate the universe. However, exoplanets are not without their challenges. They are often hidden from view by the stars they orbit, making them difficult to study. But with advancements in technology, direct imaging of exoplanets is now possible. For an exoplanet to be directly imaged, it must be large enough to be seen by a telescope, far enough from its host star to not be obscured, young enough to be hot and visible from Earth. These requirements limit the number of exoplanets that can be directly imaged, but those that are provide a fascinating glimpse into the attributes and composition of distant worlds. Exoplanets are most commonly found through the changes they induce in their host stars. A planet's gravitational pull makes its host star sway. This can be detected using the radial velocity method. The Kepler Space Telescope used the transit method, which measures the dimming of a star's light when an exoplanet passes in front of it. This method has provided valuable information about exoplanets, including their size, distance, and temperature. Here are a couple of fun facts. Did you know that more than 22% of stars, including the Sun, have Earth-sized planets in their habitable zones? Or that the TRAPPIST-1 system hosts 7 exoplanets with water on rocky surfaces? Exoplanets, like those in our solar system, can also have natural satellites, exomoons, and more than one in some cases. With more than 4,000 discovered exoplanets, we know they exist in abundance throughout the universe. Hot Jupiters, because of their mass and rapid rotation, are the easiest to find, but countless others are still waiting to be discovered. NASA's James Webb Space Telescope is revealing the universe's secrets one discovery at a time. This extraordinary telescope has been gathering data and capturing stunning images of the universe's previously unknown wonders. Recently, it made a groundbreaking discovery that will alter our perception of the cosmos. NASA announced that the James Webb Space Telescope has found the first definitive evidence of carbon dioxide in the atmosphere of a planet outside our solar system. This discovery provides crucial insights into the planet's composition and formation, offering us a glimpse into the mysteries of a gas giant planet 700 light-years away, orbiting a sun-like star. This marks an important advancement in the search for life on other planets. NASA Administrator Bill Nelson stated, "This finding will supply us with a new perspective on the universe that we've never seen before." The discovery has sparked excitement among astronomers and scientists worldwide. But that's not all. The James Webb Space Telescope has been busy taking stunning photographs and gathering data about the universe. One of its observations includes IRAS 1105177006, a young, infrared-emitting object. It illuminates a cool, spherical cloud, revealing light from distant stars that is otherwise obscured by ice. Webb's remarkable Ice Age project aims to study the genesis of ice, from its formation to the development of icy comets. The James Webb Space Telescope has even captured, for the first time, the workings of a dusty disk surrounding a nearby red dwarf star, using infrared frequencies. This dusty disk, seen around the red dwarf star, could be the cradle of future planets, the earliest stage in planetary formation. Such observations are vital to understanding how solar systems, including our own, came into existence. By studying these formations, scientists gain deeper insight into the evolutionary stages of planets, from icy particles to fully formed worlds. The James Webb Space Telescope, JWST, isn't just looking at distant planets, it's helping us redefine the building blocks of life. With its powerful infrared capabilities, it can detect the chemical signatures of water, carbon-based molecules, and other elements critical to life as we know it. This opens doors to the possibility that life-supporting environments could be far more common than we once believed. In fact, some of the most surprising discoveries have come from planets that don't resemble Earth at all. Planets with toxic atmospheres, intense radiation, or gravitational fields many times stronger than Earth still display fascinating complexity. Winds faster than sound, storms that last centuries, and magnetic fields stronger than any found in our solar system. Every new finding challenges what we thought we knew. It pushes us to ask bigger questions. What defines a habitable planet? Is life bound by Earth-like conditions? Could there be entirely different forms of life, ones adapted to extremes we can't yet imagine? The journey into the realm of exoplanets is just beginning. With missions like ESA's Ariel, NASA's Roman Space Telescope, and ground-based observatories such as the Extremely Large Telescope, ELT, we are entering a golden era of exoplanet discovery. And while we continue to gather data, one thing becomes clear. We are not isolated wanderers in a quiet universe. We are observers, slowly unraveling a vast cosmic story, page by page, planet by planet.